DDV.com.
Welcome everybody. So in this session I am going to discuss DDV Unit 1 System Tasks in Verilog. What are the system tasks available in the Verilog? So I am going to discuss one by one. First, the system task. What is system task? So every system or every operating system or every software has its own task or function that is used for certain routine operations. All system tasks appear in the format in Verilog by using $symbol, $ and a keyword. The operations such as displaying on the screen, monitoring values of nets, stopping and finishing are done by system tasks. Okay. So in this session I am going to discuss very important, mostly used system task. Okay, many system tasks are available. Okay, right? But these four system tasks are very important. Frequently we are using in Verilog programming. First one, the displaying information. So in C programming we are using printf, that is used to display the strings. Same way in Verilog programming, we want to display anything, we can use $display system task. So $display system task in a main system task for displaying values of variables or strings or expressions. This is one of the most useful tasks in Verilog. So the usage is $display open bracket, then P1, P2, P3, Pn close bracket semicolon. Here the P1, P2, P3 up to Pn can be strings, the quoted, double quoted strings or variables or expressions. The format of $display is very similar to printf, already I told. A display insert new line at the end of the string by default. So in C programming, if you want to get a new line, you are using /n, but while using display system task, automatically it makes a new line without /n. This is a default. A display without any argument produces a new line. Okay, without any argument. So no need to use /n while we are writing the code for $display. Then the string can be formatted using the specification listed in the next two slides. You will see one by one. So we can use the following formatted specification while we are using strings. The first one, to display the decimal number, we can use %d or %D. So it is not case sensitive, so we can use capital letter or small letter. Similarly, to display the variable in binary, we have to use %b. To display the string, %s. For hexadecimal number, %h. For ASCII character, %c. Then hierarchical name, %m. Strength, %v. Then variable in octal, %o. Then display the current time, that means the simulation time, t. Display the real number in scientific format, for that is E. Display the real number in decimal format for F. Then display the real number in scientific or decimal format, whichever is shorter, that is for G. Okay, these are the some specifications we can use in Verilog along with display for string operations. Let me see some examples. Consider the first one, display the string within a double quotes. So this is a keyword $display open bracket, double quotes, then we are writing them some strings, hello Verilog world, then close bracket, semicolon. This is a format. So it shows the string like this, hello Verilog world. This hyphen is automatically coming. Then second one, display the value of current simulation time 230. Already the current simulation time is 230 here mentioned. So to display the current simulation time, we can use $time. This is also one of the system tasks already we have studied. So $display open bracket $time close bracket semicolon. It is a 230. It shows 230. Then display value of 41-bit virtual address. So this is address at time 200. 200 is a time unit. It may be second, millisecond or microsecond. Okay, it is not mentioned. So here if you want to display the address, we need to declare the register along with 41 bits. So here the register declared in vector format 0 to 40, that represent 41 bits. Then here it is a identifier, that is a virtual address. Then after that we are using display command, $display open bracket double quoted line is used. In that at time %d, this d represent to display the decimal number. Then virtual address is this %h represent display the hexadecimal number. Then comma $time and a virtual address. The virtual address variable store the virtual address. Okay, 1FE that number. Then after executing, it will shows this in screen at time 200 virtual address is this value. Okay, next example, display the value of port ID 5 in binary. So port ID is given in decimal, that is 5. Okay, right. So in binary you have to display in binary. How to display? First it is a 5. Here we are assigned 5 bits 0 to 4. To display 5, 3 bits is enough, but here assigned 5 bits. Okay, register declared in a vector format. Okay, 0 to 4. Then port ID is a variable or indicator, identifier. Then we are using displaying keyword, display keyword. Then open bracket double quotes. In that we are writing our requirement, that is ID of port is %b. B represent to display value in binary, comma port ID. Okay, so it will shows the value like this 00101. It's a 5 in binary value. Okay, right. Let me some example other with some special characters. Display the value of 4-bit bus 10XX in binary. Okay, so actually the given bus value is displayed in the binary. So here how many bits? It is a 4-bit. So the register is vector to 4-bit 0 to 3. Then bus is a identifier. Then $display open bracket bus value is %b, comma bus. So the bus value is 10XX. Okay, so this way it will display the value. Then display the hierarchical name of instance P1 instantiated under the highest level module called top. No argument is required. This is a useful feature. Okay, here I am to display the hierarchical name of instance P1. So here $display. Okay, then open bracket double quotes. This string is displayed from %m. What is %m? Already here seen here. What is %m? Display the hierarchical name. Okay, display the hierarchical name. No argument is required. Okay, so that is used here, percentage M, level of hierarchy. So it shows the result. This string is displayed from top.pl. Actually, what top is what? The module, highest level module is called top. Okay, dot p1 is already mentioned here. Okay, right, level of hierarchy. Okay, so this is a procedure to display the hierarchical name. Next, some special characters we are going to use. Display the special characters and new line. Okay, then percentage. So $display open bracket double quotes, this is a /n. The /n is used for next line, multi-line string with a percentage sign. So already we have studied in the last session, if you are using 2%, it will display percentage. Okay, right, already we have studied. Then the result will be, this is in first line, then /n represent next line, then multi-line is start at the next line string with a percentage sign. Okay, right, so this is a display the special characters. Okay, right, so likewise we have to use the display system task in our Verilog programming. Next we are going to see the second system task, that is a monitoring, information. So this system task continuously monitor the particular variable or particular signal or particular wire. Okay, Verilog provide the mechanism to monitor a signal when its value changes. This facility is provided by a $monitor task. So the monitor is represented by as like this display task $monitor open bracket, then some p1, p2, p3, pn's, then closed bracket. These are the parameters, can be a variable, signal name, or double quoted strings. A format similar to display task is used in the monitor task. The $monitor continuously monitor the value of variables or signals specified in the parameter list and displays all the parameter in the list whenever the value of any one variable or signal changes. Unlike display, the monitor needs invoke only one use. Okay, right, only once. The monitor is executed only once in a program, but display is executed many times, right, as per the requirement. Okay, here the monitor is monitor the signal or wire or net, okay, or variable in continuously, and it display the values when it changes. Okay, when the signal or variable changes. Okay, right, so monitor is needs to be invoked only once. That means only one monitoring list can be active at the time. In our Verilog programming, we are having a 2 or more monitor system task, means any one monitor task only active at the time. If there is more than one monitor statement in your simulation, the last monitor statement will be the active statement. The earlier monitor statement will be overridden. Okay, so the last one will be an active one and the previous one is in overridden condition. Two tasks are used to switch the monitoring on and off, to enable and disable the monitoring. That is, to enable the monitoring, $monitor on is used and $monitor off is used for disable the monitor. Okay, the monitor on task enable the monitoring and monitoring off task disable the monitoring during the simulation. If the monitoring is used in our Verilog program, it is turned on by default at the beginning of the simulation. and can be controlled during the simulation. We are using monitoring on and monitoring off task. In default, the monitoring is automatically switched on at the beginning of the simulation, but if we want to stop the monitoring in middle, we have to use monitoring off, and again if we want to enable the monitor, we can use monitor on. Okay, so this is a monitoring. So here see some examples. Consider monitor time and another one clock, okay, of the signals. And actually here we are using three terms: time, clock and reset. The clock toggles every 5th time units and the reset goes down at 10 time units. Okay, this is a condition. Clock toggle for every 5. So initially the monitor starts at 0 time. Okay, then the initially assume clock equal to 0, and another one condition is mentioned here, that is the reset is active high, that is 1 at 10th time. Then before that the reset should be in 0. Okay, so initial is the one of the keyword that is used in the Verilog programming, that is used to declare something, that is in the declaration. Okay, used for declaration initially. Then begin and end is the one group, begin and end. In our C programming, we are using the open bracket and closed bracket to write one set of instructions. Same way here begin and end is used. So $monitor open bracket $time, we are using a time, then comma double quotation, value of signal clock equal to %b, that represent to display the binary number, then reset equal to %b, that is also binary number, then comma clock comma reset, then end. If we are using begin, then if you have to use end. So now one group is completed. After the execution, the partial output of monitor statement will be like this. First 0 value, the time value is 0 at beginning of signal clock equal to 0. The signal clock is equal to 0, then reset equal to 1. Then after 5th time, so here first 0th time and 5th time. Here already mentioned it's a 5th time, so 0 to 4 not like that, it is a 5th one. 5th value of the signal, the clock equal to 1 and reset equal to 1. Similarly at 10th value of the signal, clock equal to 0 and reset equal to 0. So this way the monitor produces the output. So this monitor monitoring the values changes in the signals. What are the signals we have here used? The clock and the reset is the signals with respect to the time. Okay, so this is the examples of monitoring statement. Next one is stopping and finishing the simulation. In C programming we are using break. Okay, so the break is used to suspend the execution for some time. Okay, temporarily stop the execution. Similarly here the task $stop is provided to stop during simulation. The usage is $stop semicolon. So this $stop task put the simulation in interactive mode. Okay, interactive means the simulator and the designer interactive something. The simulator gives some inputs and the designer gives some input and the simulator produces some output. They are verifying the outputs and examine the values in the particular signal or wire or some variable. The designer can then debug the design from the interactive mode. The stop task is used whenever the designer wants to suspend the simulation and examine the values of signals in the design. Okay, so to stop the simulation temporarily and examine the values of signals in the design. The $finish is the task that is terminate the simulation. to complete the simulation, $finish is used. Okay, in embedded system, halt is used to finish the simulation. Okay, right? So usage is $finish. Okay, right? See some example. Stop at the time 100 in the simulation and examine the results, then finish the simulation at time 1000. This is a given data, so we have to write the program for this given data. So what are the data given? So stop the simulation at 100 time unit and examine the result. After that, finish the simulation at the time 1000. So how to write? The first instruction is initial, then begin. Initially we assumed that clock equal to 0, then reset equal to 1, then at here hash 100 that represent the time delay. Okay, right? At 100 time we are stopping the simulation by $stop task. This will stop and suspend the simulation at time 100. Then after that, after 900 seconds, the finish will be executed, because our requirement is, our question is the simulation, finish the simulation at time 1000. Already 100 is used, so 100 plus 900 total is at 1000. Okay, after 900 seconds the finish is used. Okay, finish just terminate the execution or simulation. This will terminate the simulation at time 1000. Then we are end the program. If we are using begin, then we can use the end. Okay, right? So these are the 4 important system tasks used in the Verilog programming. What are the system tasks? First one is a display, then second one is a monitor, and third one is a stop, and the fourth one is a terminate. That means the finish. Okay, so these are the important system tasks used in the Verilog programming. Thanks for watching.